Welcome back. In this video, we'll start building out our password application. So yes, in the previous video, we built out the foundation for the authentication. We built session store. We built the base user authentication, the user model. And in today's video, we will go through how we will build up the password application, which is a separate module. And so the idea here is that we have a separate module such that when we eventually would want to implement Google authentication, we can add that as a module as well. We could deprecate the password authentication if that's what we want to do without affecting the rest of the system. And this is basically what we will be focusing on today. And so if you recall, our setup is we have a front end that's up running here. We have a blockchain that's running here. We have our database that's running here, and we have our backend that's running here. We are now going to stop our backend. Oh, bloody hell. That was not what I wanted to do. Let's see, did that one go somewhere? Okay. That's what happens. Sometimes things doesn't go exactly as you want them to split vertically. Oh, that's neither what we wanted. We want to split horizontally. Split horizontally, default profile, okay. And what was the working directory? I actually do not recall. Okay. Okay, let's just test that that is not running somewhere in the background. So sorry about that. Minor slip up here. Yes, okay, good. That one is not running. Let's just test that everything is working as it's supposed to. Cargo run. Okay, and our backend is back up running. So we navigate to the root folder, and inside here we have our auth app, we have our app configuration, we have the main application, and we will now make the auth password. And just like the previous ones, we're going to have 3 crates. We're going to have one for the API and database interaction. We're going to have one for the backend and one for the front end. And so I'm just going to go ahead and make those ones. Password API, and these are libraries. Oh, create, that's new app and screens. Okay. So the first thing we want to do is implement the library that we want to have. And the API library. So the first thing we want to do is implement the API and the API types. And inside of here, we're going to have a few different types for authenticating ourselves. So But first, we are going to add the types that we need. So we're going to import those ones. We need the user, and we need serialize and deserialize, and then we need validate. Right, so validate is a framework that allows you to use macros to specify the constraints of a specific data type. And then afterwards, it will have some functions that allows you to validate what you need to do. We also need to add the dependencies. So we have the normal serialization framework. We will use the workspace version of it. We need time, so we're going to add chrono. This is again on workspace. We need the UUID. This is what we use for the user ID, workspace. Then we need SQLX. This is going to be an optional dependency because we'll only enable this one for the backend implementation. We're going to add optional equal true here for that reason. And then we need the auth app, the validator, and then we need to define the feature. Okay, cool. Getting back to the file itself. We'll start out by doing the usual derive, and then for this first struct we're making, we want it to be validatable, we want it to be debuggable, we want to be able to clone it, we want to be able to serialize it, serialize, and deserialize. And this is going to be our login response. For registering the user. And so that will return a status, which is a string, and then it will return some data, which is a user. And in the event that we can't create a user, we'll usually return an error response. So we don't need to deal with that in the normal thing. So we don't need to deal with error responses within the normal struct. Let's also add a login response, which is just when the user logs in. And finally, we want to have some requests as well. We want to have a login with password. And we want to have a I am confusing myself. Right, okay. So we want to have a user password. So this is going to be our database type for storing or associating a password with the user. So we have the user ID and their password. This is going to be a hash password, so we do not know exactly what the such that we do not know exactly what the password is, and we cannot use a rainbow table because we'll be salting it and doing all the normal best practices of that. Next, we are adding a login form, and for this we're going to use the validate framework. So again, we have validate, debugged, we have a default for it, and the login form is going to ask for an email and it's going to ask for a password. And finally, we will need a sign-up form, which we will use for allowing the user to sign up, and that will have a name, email, and password. And this is about it for now. Then the next bit we are going to work on is the actual backend. And we'll follow the same structures we've done in all the other all the other modules. We'll add a file that's called handlers. And inside of the handlers, we're going to define all our usual handlers for dealing with user requests. And so we're going to have one for registering the user, one for logging in. And that's it for now. We could then extend it with forgot password and all of these usual things you'd want to have. But for now, we're just going to do sign up and log in. Then we will also need a services module. And just like the previous, so normally we would create a repositories module and a services module, but in order to keep things short and simple, we're going to just go with a services module. Writing out the library itself, we will write mod handlers and mod services, and these ones are added to the library immediately. Next, we want to add the dependencies. And so we have a whole bunch of dependencies we're going to use here. We will be using base64, we will be using chrono, we have some password specific things, which is argon, hash password, and then we're going to rely on the previous auth modules we have implemented. So we'll need the auth API, we'll need the auth app, and then we'll need our auth password API and our app config. And that is about it. And so for our own modules, we are enabling the backend because we are writing the backend out now. Okay. Moving to the services, we'll start out by creating a debuggable struct, which is just our auth password service. So just like our auth service, this will go in as an extension into Axum. It will have a pool to interact with the database. And we will implement this with a new function. And then we need a verify password. And as usual, we are going to return a result. We either succeed, in which case we are going to return a Boolean that tells you, did the password actually verify or did it not? Or we're going to return an error response, which is our path in case that something goes wrong with the database or anything like that. We still need to define the table for this. So let's just add a to-do here for now. And then define the table in just a bit. Likewise, we will have an update password, which is also just going to be to do for now. And we'll have a create password, which is what we will be using when the user is signing up, right? So when a user signs up, we'll first create the user and then we'll add the password for the user after that. And that's also going to be a to do for now. Good. In a slightly more complicated version of this, or in a more complete version of this, you would have service functions for sending out emails, for resetting the password, creating a reset token, and all of these things. We're not going to do that in this video. Once you have made the base layer here, extending it with these functions are relatively straightforward. So let's go back to our terminal, and we now go to our app backend. Oh wait, app. Let me just see, did I? Yes, the structure became right. So we go to app backend, and then we do SQLX create. Oh, I think it's migrate at. And we're going to add auth password. And so our auth password is going to be completely straightforward. We are just creating a table that's called passwords. So we always use the create module first here, and then what table it is within the create module that we are looking at. And so the create module in our case here is auth password. It contains three creates, but we have grouped those ones together as a single module or component within our system. And so we're using that to make sure that we don't collide in the namespace. Then we are linking a user ID from our user table with a password and making sure that we are cascading the right way when we're doing a deletion. Okay, cool. This gives us the foundation for implementing the actual service now. And having done that, let's head back to the service and start implementing the verify password. And so this becomes relatively straightforward. The only non-trivial part of this is that we're going to do encryption of the password to prevent anybody from ever getting the password out of the database. We'll use that auth password only struct that we defined in API. So the idea here being that sometimes we just want to get the, did we forget to implement this one? Oh, I think we forgot to implement this one. Or did we implement, wait, I think we implement, wait. I think we implemented it up here, didn't we? No, we didn't. Okay, let's just fix that. We need to implement a auth password only, which allows us to get the password. So we're going to implement this one in our API as well. So this is a database object. So we're going to implement it next to this one we have here. And the idea here is that sometimes we only want to have the password. We don't need to have the user ID. So we need to be able to extract that from the from the database. Right. So getting back to our services, we are going to query for auth password only. And we'll do that with a simple SQL query, select password, and then from auth passwords where user ID. And again, remember we use this $ number, and then we bind the actual value to prevent that we are getting in a situation where you can do an injection attack. Okay, so this will get the password out of the database for us. Next, we want to check whether this password is actually valid. And for that, we're going to use the create password hash and just create the password with the stored password, and then pass the hash, and then verify the password using argon2 and bytes that we are having. And this should return whether the password is valid or not. And finally, we return OK is valid. Update password follows pretty much the same idea, using the verify password to check that the current password was actually correct. Then generating a new salt, using argon2 for generating the hashed password, and then we update the hashed password. And again, the create password is pretty much the same as again. We generate a salt, we hash the password, and then we insert that into passwords. Okay, getting to the handlers. We are going to import our API types for logging in, for getting responses, for setting up the form, and getting the user login response. Then we have some different things we need from Axum and Tower to get the session, to define the handlers and all of that. And we have our error response from the app config. And finally, we have our password service, which we'll be using for defining these handlers. And so we basically have two handlers we want to define. The first one is register user, and the second one is login. So remember, our auth module already has a logout function, so we don't need to re-implement that here. We are just going to implement the login function. And finally, we will have our app, which is a router that adds auth register and auth login. And that's pretty much it. So the first thing we want to do in the register handler is checking that the that the input is actually fulfilling the criteria that we want to have, which is defined by the validator create. We're going to do validate, and if there is an error, we will return a error response with that the data submitted was not valid. And in the logs, we're going to put output and log saying, this is what happened. This will help us debug when things are going wrong. Then once we have done that, we'll define the user. So the user will get a new UUID. We'll add a name. We'll add the email as the username. The role is just user, when it was created, when it was last updated. And with that, we are ready to use the auth service to create the user. So this was the auth service we defined in the previous video that has this function create user. And so either this will succeed or it will return an error response, in which case we are mapping that back into a response that will be given on the platform or on the API side. Having created the user with a user ID, we can now add the password. So we're just using our password service, create password. So this was the function we had defined in the service here, create password. We're now using that in the handler saying, okay, now we're creating the user password. And if this fails, we're going to write that out to the terminal so we can see in the logs what happened. And we're returning a user response or an API error response. Finally, if everything went well, we will return that things were okay. We got a user registered and the status is success and the data is user. So pretty straightforward at this point. Our login is following pretty much a similar pattern where we'll be using a combination of the two services we have. We have the password service and the user service. And we will use that to basically do the login. So let's just quickly go over the code here. The first thing we do again is we validate the input. If it doesn't validate, we'll return an API error. Next, we verify that the user actually exists in the system. If it does, we get the user object, and then we check that the password is valid. If the password is valid, by calling our verify password function on the password service. Again, we will be looking to the terminal what we are. If we experience any errors, this will help us debug at a later point. If it's not valid, we will also log that to the terminal. This will help us trace exactly where things went wrong, and then we are returning a bad request, bad username or password. Finally, if we found the user and the password checks out, we update the user session. So we create a new user session with the user object, and we insert that into user session. So if you recall a few videos back, we created a session object which contains the user object and allows us to store the user persistent across multiple requests on the API. And this was done using cookies and a Postgres backend for storing the sessions. And finally, we return off user response, and this would be successful. Okay, this pretty much concludes today's video. In the next video, we'll build out the front end and actually test that all of this is working, and just see how we can get the whole login flow to work. And this is going to be super exciting because we're getting very close to the end, right? We have the back end now. We have the functionality for logging in. We have on the front end the ability to build up a wallet and the ability to send transactions, receive funds, and all of that. And so with the login, once we can log in, we can then create the wallet API that will allow us to store the wallet on the backend, encrypted, of course. But that gives us basically the full stack application with a backend that stores all the information we have, a Web3 component that we can interact with, and a front end all written in Rust. And I'm super excited to get to the next bit with you. So if you like this video, subscribe, follow,